Welcome everyone. In this walkthrough we'll look at the reactions of amines, reagents conditions and the nucleophilic substitution mechanism. We'll then go on to look at the base strength of amines compared to ammonia. The final part of the question deals with chiral sensors. Here's the format that I use. This is an AQA A-level chemistry year 2 past paper question. Details are in the description. Let's get started. Pause the video, read the question and press play when you're ready. There will be lots of marks available for students who know the organic reagent conditions for their specification. Haloalkanes will undergo nucleophilic substitution reactions with ammonia. If excess ammonia is used, the primary amine will be the major product. The first mark is awarded for getting the organic reactants and products correct. The second mark is for balancing the equation correctly. Excess ammonia minimizes the chance that an amine product will go on to react like a nucleophile and make secondary and tertiary amines. One molecule of ammonia substitutes for each halogen in the haloalkane. One molecule of ammonia mops up H+ ions that are formed to make an ammonium ion, NH4+. Bromide ions are also formed. We'll take a look at the mechanism to show the formation of the products in the next part of the question. The inorganic product is ammonium bromide, NH4Br. The correct balanced equation is shown here in blue. Here's the next part of the question. Pause the video, read the question and press play when you're ready. First, let's look at the mechanism. This is a nucleophilic substitution reaction. A nucleophile is an electron pair donor, ammonia in this case. Curly arrows show the movements of an electron pair. This is associated with bonds breaking or bonds forming. Curly arrows go from the center of a lone pair on a nucleophile to the atom that a bond is formed with, or they can go from the center of a bond that is breaking to the atom that receives the pair of electrons. The black arrow shows the carbon to bromine bond breaks. A bromide ion will be formed. Two dots show the lone pair of electrons on the nitrogen atom of ammonia. The blue arrow shows that the lone pair of electrons is making a covalent bond with the carbon atom. The intermediate is formed. The nitrogen atom on the left is now making 4 covalent bonds. It has a full positive charge. One of the NH bonds breaks and both electrons go to the nitrogen atom. The final step shows the formation of the amine. H+ ions are also produced. If you look back at the first part of the question, you'll see that ammonium bromide is also a product. H+ ions are mopped up by excess ammonia molecules to make the ammonium ion. Bromide ions are also present. Next, let's think about the secondary amine byproduct. Ammonia is a nucleophile, an electron pair donor. Amines can also behave as nucleophiles. There is a lone pair of electrons on the nitrogen atom of amines. The nitrogen of the amine group can form a covalent bond to the CBr carbon at the other end of the same molecule. Here, I have just shown the nucleophilic attack from the lone pair on the nitrogen. One possible answer is shown in blue. Another possibility is for two haloalkane amine intermediate molecules to react together. Once again, I have just shown the nucleophilic attack. The other possible answer is shown in blue. Here's the next part of the question. Pause the video and press play when you're ready. You should be aware of the two different ways that amines can be produced. We've just looked at the nucleophilic substitution with aqueous ammonia in the previous questions. The two-stage process that we will look at here is commonly used in industry if the primary amine is the desired product. This preparation does not lead to the formation of secondary and tertiary byproducts. In stage 1, dibromobutane reacts with cyanide ions. This is also a nucleophilic substitution reaction. Alcohol is chosen as a solvent rather than water. This prevents hydrolysis of the carbon to bromine bond. In the second stage, the nitrile functional groups are reduced to form amines. Hydrogen is the reagent. A nickel catalyst is also used. Here's the next part of the question. Pause the video and press play when you're ready. A base is a proton acceptor. The alkyl group in 3-aminopentane is electron pushing. 3-aminopentane is better able to donate a lone pair of electrons on the N atom to a H+ ion. You should also be aware that phenylamine is a weaker base than ammonia. The lone pair of electrons on the nitrogen atom of phenylamine is delocalized into the pi ring system. And here's the final part of the question. Press play when you're ready to go through the answer. A carbon atom that is bonded to 4 different atoms or groups of atoms will be a chiral center. No chiral center is present here because no carbon atom that is present is attached to 4 different atoms or groups. Thanks for watching. There's plenty of useful links in the description. Post in the comments if you have any questions or suggestions. Take care and good luck with your studies.